When you name molecular compounds, you can also name them with a Roman numeral, and the Roman numeral indicates the oxidation number on the elements. And so let's talk a little bit about oxidation numbers and how you determine what the oxidation number is for an element. So oxidation numbers can be used when naming molecular compounds to indicate the general distribution of electrons among the bonded atoms. Assigning oxidation numbers. So pure elements, so that means they're not bonded to another atom. So like O2, Cl2, are assigned an oxidation number of 0. So Na, if it's by itself, O2, P4, S8, they would all have an oxidation number of 0 if they're not bonded to someone else. In binary molecular compounds, the least electronegative element is written first and is assigned a number equal to the positive charge as if it were a cation. The more electronegative element is assigned the number equal to the negative charge as if it would have been an anion. Fluorine is always given an oxidation number of a -1. Now let me say this, when you're assigning oxidation numbers, you put the plus or minus in front of the number. When you're doing a charge, you typically do it as a superscript behind the element symbol. Oxygen is usually a minus two oxidation number, except for if it's a peroxide, such as H2O2 is hydrogen peroxide, where oxygen then would have a -1. And when it's in a compound with a halogen, such as OF2-, now oxygen would have to have a +2. Hydrogen is normally a +1 when it is the least electronegative. If it is a -1 in a compound with a metal. So if you put hydrogen with sodium, so NaH, then your sodium is a +1, so your hydrogen would have to be a -1. The algebraic sum of the oxidation numbers of all atoms in a neutral compound is equal to 0. So we'll work some examples in a second. The algebraic sum of the oxidation numbers of all the atoms in a polyatomic ion is equal to the charge on the ion. Oxidation numbers can also be assigned to atoms in an ionic compound. And in a monatomic ion, if it's not bonded with anyone else, its oxidation number equals to its charge. So if Ca2+ is hanging out by itself, then it has a +2 for its oxidation number. Okay, so we're going to assign oxidation numbers to the following. So you have UF6. So we know, well, who do I need to look at first? Which one do I need to look at first? Well, you know fluorine is always a -1. So I write my oxidation numbers above, and then I do my bookkeeping beneath. So fluorine's a -6. So, fluorine is a -1. You have 6 of them, so 6 times -1 makes this a -6. This is a compound, so we're going to make them equal to 0. So if this is a -6, then that means uranium has to be a +6, so equals 0. So uranium is a +6, fluorine is a -1. Okay, H2SO4, so let's look at oxygen first. It's not in a peroxide, so we know it's a -2. There are 4 oxygens, so that makes this a total of a -8. This is a compound. We know it's going to equal 0. Hydrogen is almost always a +1, so you put a +1 here. You have 2 hydrogens, so that makes this a +2. Now, what would sulfur be? So +2 plus what? And then -8 would equal 0, so that would make sulfur a +6. Okay. ClO3-. Now, this is an ion, so our sum of them has to equal a -1. So oxygen, once again, is a -2. We have 3 oxygens, so 3 times a -2 is a -6. So therefore, chlorine has to be a +5. A +5 and a -6 is equal to a -1. Now, you can use oxidation numbers to write formulas and names, and this is called the stock system. So this is when you would give a molecular compound a Roman numeral. So when naming, use Roman numerals to indicate the oxidation number of the first element. So name each of the following using the stock system. So we have Ci4. So we're going to look at iodine. So iodine is a -1. You have 4 iodine, so that makes this a -4. So that means carbon must be a +4 because you want them to equal 0. So you would name that compound carbon Roman numeral 4 iodide. Okay. Your next one you have SO3, and you're going to name it stock system. So we need to figure out the oxidation number of sulfur. So we're going to look at oxygen first. Oxygen's a -2. 3 times a -2 is a -6. So this sulfur in this instance has to be a +6. So you would name this sulfur Roman numeral 6, Vi oxide. AS2S3, so we're going to look at sulfur once again. So sulfur is a -2. You have 3 sulfurs, that makes this a -6. So this side has to be a +6. So that means each arsenic has to be what? A +3. So you would name that arsenic Roman numeral 3 sulfide. And our last example is NCl3. So we're going to look at chlorine. Chlorine is a -1. You have 3 of them, so that makes this a -3. This is a compound, so they have to equal 0. So in this case, nitrogen must be a +3. So you would name that nitrogen Roman numeral 3 chloride. So this is how you would name molecular compounds using Roman numerals, and the Roman numeral would indicate the oxidation number on the first element. Thank you.